Connects it.
It connects the different pieces.
It connects it different.
So when I was last here, I made the overall body. I did this cutout, okay, that I call the front cavity. And I couldn't just cut out this square rectangular part as a part of that. I had to re-add it. Okay, and the reason why is it comes up to a different height than the original surface of wood. Okay, so I don't really know what you want to call this. I want to call it the rectangle. You can call it whatever you want, but everybody's is going to be the same. That part doesn't change. It is the same rectangle on every single car. The other side, however, is not the same. The other side is different. If you look at mine, I have squares. I have squares. Your car will have, I think one of them is circles, and one of them is ovals, and one is triangles.
Right.
Depends on what car you have. Orange is triangles.
Diamond.
Purple's triangles.
Diamond.
Diamonds. Okay, purple's diamonds.
Square.
Green is squares. Then we got the blue or light blue. There's a dark blue and a light blue. No?
I mean,
No, I know. I'm asking the three people who are actually doing this. I know, shocking. Wow. Okay, so I'm gonna do this, and we're gonna start with a basic premise here that this thing is centered. Now, maybe in general things like that are not centered, but I'm gonna operate the assumption that it is. It certainly is centered left and right, or should be, right? It looks like it's centered up and down as well, so we're just going to go with the assumption that's how it was meant to be. It's going to be centered up and down as well, all right? So I'm going to make a sketch. Maybe I'll rename this front rectangle, just to be clear.
see there.
And what I'm going to do now is I'm going to add the other side. So I'm going to make a sketch on what's basically the back side now. Okay? And I'm going to do similar to what I did before.
Mr. Covington, can you please submit your attendance?
Sure.
Thanks.
Sir.
Yeah, it's okay. I already did it anyway. We literally went over the attendance earlier in class. That's fine. So what I'm going to do is I'm going to do a center point rectangle on that origin. Now, the dimensions that I use for it, all right? So we decided that we were going to treat this plastic as just part of the wood because we don't have the way to take the plastic out and really measure it ourselves. So we're just going to treat it as the same. So you should get your calipers and you can make those dimensions, those measurements. Now, they could, hypothetically, it is possible that they would be the exact same as the dimensions on the other side. But I wouldn't necessarily assume that, all right? Just to check this out, when I measure, you know, these that I'm doing right now, I'm getting like a little over 55, and I go to the other side, and I'm getting like almost 58. They are not quite the same. And if you look at the connector piece, you should see that. The top and bottom of the connector piece are not quite the same sizes. So you have to be careful with some assumptions. I assume that it's centered. That assumption is probably valid, but assuming that they're the same size would have been really, really bad. Okay? Would have been really, really bad. So make sure that you actually measure it. Don't use the same numbers. So I'm going to go and do this again. And I'm trying to measure sort of like the inside width, and I'm getting something like 55, maybe 55.1. So I'm making my width 55.1. And then for my height, I'm getting something like 17.6. Okay. Something around there. So I have my rectangle. And then I'm going to do my fillets. You're going to have to ballpark the radii of those. It's not necessarily the ideal way to do it, but you're just going to have to kind of guess, do your best there. It's somewhere around 2 or 3. Okay? Somewhere around there. Not going to get caught up, what the exact number is. But maybe 2 would work. So I'm going to do all of these. Notice I'm clicking on each corner. And then I get that green check mark on the left mouse. You can see that icon there. It's prompting me to click the left mouse button on this empty space to confirm. And now I can type whatever number. I'm going to type in 2. Go with 2 for now. I can always change it. Going back into this sketch, I'm going to move that dimension there so it's easier to see. And I can now extrude. And I'm going to do that. So this would be if I call the other one the front cavity, I can call this the back cavity or rear cavity. And I'm going to extrude it. And how far I go, I'm going to use this is the thing on the end or the bottom of the calipers. I'm going to use that device to get the depth. That's what that is, the whole depth thing. Somewhere around 12.6 maybe. Almost 13. It's going to go with 13 for now. And since this is a hole, I will want to choose remove. So I have my back cavity done. And it is a little bit smaller. A little bit smaller. Not much smaller, but a little bit. And I'll call that, again, I'll rename that to the back cavity. Then what I'm going to do is I'm going to add my shapes. So I have squares, which are very easy. Yours might be different. They might be triangles, ovals, circles, whatever. So what I'm going to do is I'm going to make a sketch in here. And I'm just going to go over briefly how you can do various shapes. If you want to do a circle, I got circles right here. And I would line the center of the circle up with this line. That is actually a plane, but when I look at it like this, it just appears to be kind of like almost like the x-axis, okay? So like I could do a circle like that and a circle like that. The horizontal constraints have lined it up. I could use an equal constraint to make them the same size, and then all I have to do is dimension the size of 1, okay? There's some other tricks you could do to position them so that they mirror each other. But the key is that the center of the circle would line up with this horizontal line or the origin. I could do ovals. So if I go to the circle tool again, there's a drop-down arrow. I can click on it, and there's ellipse. And the ellipse is just an extra step. First click places the center. Second click places how big it is in only one direction. And then the second direction, that's your third click, is actually placing like how big it is the other way. Okay. Again, though, it's very similar to a circle. The center of it should probably be on the same line as the origin. If you have a regular polygon, not a square, but a triangle, pentagon, anything like that, right here is this polygon tool. You can do the inscribed or circumscribed, either or. Okay. You click to place the center, and then you click to place like what's indicated the rough size of it, and then you kind of just pan to change the number of sides. Now, let's say I do a triangle. here's the thing of a triangle. If I line up the center of the triangle to be lined up with the origin, notice with this triangle that if I did that at the center, the quote-unquote center of the triangle was lined up with this, that the triangle is not actually centered. Because this is not the center of the triangle, it's the center of a circle that's inside the triangle. And I hope it doesn't take a genius, you can just look. You can see there's clearly way more above that circle than below, right? Because this is a point on this side, and there's 2 points going at angles on the bottom side. So if you do a regular polygon, like a triangle or a pentagon, you probably do not want to line up the center of the circle on that line. That'll probably not give you the desired result. For me, I am doing a square. So I'm going to do a center point rectangle because I know that I want my center to be on the same line as the origin. So I have 1, and then I have 2. I'm going to measure them. I got 11 and a half.
How would you do the diamonds? Like, what would you do for the diamonds?
For the diamonds, I would take the line tool and I would start on this line. Yeah?
Yeah.
I would go up, go down. Make sure you don't accidentally force like a perpendicular constraint, like that. Don't force a perpendicular constraint to the previous line. Just draw a line. What's important is that these 2 are on the line, right? Yeah?
Yeah.
And then if you go to the equal constraint and you make all 4 equal to each other, now you have a diamond. Are we good?
Yeah.
All right, I'm going to draw my squares again. So I had 11.5. And I'm going to use an equal constraint. I'm going to make the top equal to the side. I'm going to make the top of this one equal to the top of this one. And I'm going to make the top of this one equal to its side. So these squares are now the same size, and they're squares. So now I just have to dimension how far each is. So one thing I can do is I can measure the gap between the square and the edge. And that's what I'm going to do. I think that's the easiest way to do this. I got about 4.7. So what I dimension there, if you want to watch how I dimension distances between 2 objects, I click on the dimension tool. I want to dimension how far this edge is to this edge. So I click on the first edge. And then while I saw the dimension tool going, I click on the second edge, and it'll give me the dimension of distance between the 2. All right. And that was, again, 4.7, something like that. Now, if I did not want to have to do all this work to make this second square over here, what would be the easiest way to make that square be perfectly symmetrical and identical in every way? What could I do instead of redrawing and redimensioning that whole side?
Mirrors.
I can mirror it, right? So, I mean, it's only one more dimension I have to do, and I already know the number. So it wasn't that hard. I was able to use constraints, but it still took me some time to click on all those constraints. So, yeah, mirroring would be faster, right? Because think, all that time I spent doing some of those equal constraints and dimensioning it, okay, I could just click mirror. But then the thing with mirror is, after I select a mirror line, it says select entities to be mirrored. Well, I had to go click all those lines and stuff, so there's pros and cons. You can click and drag, though, and if you do it precisely, you can click and drag to select just that square, which is what I'm doing, and it worked out. Okay, so I have my square. So I'm going to call this the back squares. And I'm going to extrude them. And how far I extrude them, I mean, I want you to look at your shape. Do they seem to come all the way up to the top? I mean, I'm getting an overall depth of 12 point, maybe 8 or 9. Depending on how I orient my calipers, what angle I put them at. 12.8 maybe. But when I go to the square, it's like a little bit more. It goes in a little bit more. I'm only getting like 11.8 maybe. 11.9. Maybe just 12. So I'm going to say these are like maybe 11.9. They're not as much. So I'm going to rename that to back squares. And I'm done with the back squares. We're going to now do the top. So your top is probably symmetric left and right, but it's not necessarily symmetric front and back. What I mean by that is this gap up here at the top, which was like the front, is not necessarily the same as the gap on the bottom, which is basically the back. Okay? So I'm going to draw a sketch on top now. All right, I'm going to draw a sketch up here. Let's place a sketch there. And I'm going to do a center point rectangle again. But I'm only aligning the center with this plane. I'm not necessarily centering it inside the shape. What I'm saying, I'm going to exaggerate this once my thing loads, at least. Okay. I know that the left and right side are symmetric about the center of the car, but the top and bottom may or may not be. So I'm going to get my overall width somewhere around 50, 50.3 maybe. Sounds like a good number. And I'm going to get the overall, I guess, the way I have it oriented, it looks kind of like a height. It looks like maybe 40 point something. .6. Now what I'm missing here is I have to position it. So I'm going to dimension it relative to the front, which is the side that has just the one single rectangle. I think it's something like maybe 19.6. So to dimension that, I'll click on the dimension tool. I'll click on this bottom edge. I'll click on this other edge. And I can put that number in there. All right, again, 19 point something. And I'm getting like 19.4. Which is not the same as the other side. The other side is like 21 points, and they're clearly not isymmetrical. So don't assume symmetry when there is none. Now, I do have some corners around. I'm going to have to ballpark those corners, though. Maybe 5.5. Maybe. So I'm going to use the fillet tool, and I'm going to click on each of these 4 corners. You can see I selected ones that are orange. I'm going to move my dimensions so it's easier to see later. And I'm going to call this the top cavity. I'm done with that sketch. I can rename it and call it the top cavity. And then I'll just extrude it. Now this one, I want to make sure that when I extrude it, I want to make sure that I go all the way to the wood. So we'll just ignore the plastic piece of all the weird shapes. Let's ignore that. In like maybe 29.1. And there's that. So I'm done with this piece. This is the passenger section, and I am done with it. We have questions. Questions? It would not hurt to have this piece open while you make the next piece. Why? Because the connector piece has to fit into this. And so I might make some measurements with my calipers on this, but hypothetically, if I was theory crafting this, those dimensions should line up. So if I know the size of this square hole here, I should know the size of the same square-shaped object on the connector piece that meshes with it. Okay. Well, that's that. We're done with that piece. So now I'm going to go back and we're going to make the connector piece. So I'm going to click on Create, Document, Connector Piece. So this connector piece basically has a profile shape that looks kind of like whatever you see when you look straight at it. And I'm going to draw that. And I'm going to extrude. But you can see that there's like a bottom base that has a lip or whatever. And then there's like a top half that's a little bit smaller. Because those are the 2 halves fitting into the 2 different pieces of wood. So I'm going to draw this on the front plane. Now there's a variety of ways that I could draw this. I'm going to show you a way I could do it. I'm not going to claim it's the only way or even the best way, but it's a very quick way. So if you watch here, I'm going to do this center point rectangle. Okay, if you watch, so I click on the origin and I do a center point rectangle. All right. And then what I can do is I can draw another center point rectangle where the center is lined up with the origin. See how the origin's all orange? All right, I can click there. And notice how, as I'm about to place it, do we see the vertical constraint is about to get auto applied? So that's going to line up those 2 edges with each other. There we go. I have made my basic profile, so to speak. All right, I've made my basic profile, so to speak. What I'm going to do now is I'm going to use dimensions and some equal constraints. I'm going to make this the same width as this, and this the same height as this. And the idea by doing that is that I've made my left and right sides at least equal or the same. Now I actually need to get some dimensions in here. So what I'm going to do is I'm going to do the thicker part first. This would be the part that has just a rectangle in it. I'm going to do that part first. So the height, and by height I'm referring to the way it's oriented, you know, in my document. Looks like it's about 20 point something, 1 or 2. But you may recall, you know, this has to fit. This is supposed to fit within a hole that we already created. So let me go back to that other piece that I made. Here's the passenger section. Now, I hope, maybe, this will help you appreciate why we want to make sure that we label every single thing. The reason why is I've already made this entire part, but I want to go back and I want to check one thing. And it's very easy to do that because everything is labeled. They've labeled everything. Except for, I guess, this last one, I forgot to label the extrusion. That's okay. So I want to know, for example, how wide this hole is right here. Well, that's trivial. I just hover over the front rectangle or front cavity, and I can just go to that sketch, and I can see, you know, it's 57.7. It's 20.7 tall and 57.7 wide. And if I don't know if I like those numbers, I can go back and I can remeasure them. And those numbers seem reasonable. And then I can go and I can measure the actual thing that's going to fit in that hole. All right. And I'm getting, again, about 20.2. So there's about 0.5 millimeter of tolerance. The hole is about 0.5 millimeter bigger than the thing that goes inside it. So there is some consistency there. Okay? So 20.1, that measurement checks out. So I'm going to go back in here. Okay? $20.1. I can get an estimate for the width. I know there's some rounded parts there. $21.2. You just have to do your best with the rounded stuff. Yeah. Yeah. Now, one thing I'm going to point out, I'll deal with these later in some form. I got these like little things. I got my finger and thumb on them. They're like, I don't know, clips. They squish inward. I'm going to do those separate. I'm not going to do them as part of this initially. I'll deal with those separately. So I'm not going to worry about those. So I'm going to pretend like they're not there, if that's possible. I'm going to pretend like they're not there. And I'm getting something like 11.4. So the only thing I really need to do is determine the overall whatever. And for me, I think it's actually better to just go with the overall width. So I'm getting about 58. Do it one more time. 58. If I go and I measure the width of the hole, the very hole I measured the width of was like 57.7. So I want you to think now, is a 58 size object fit in a 57 size hole? Does not. So then go back and I can measure again. I feel pretty good about my width measurement on this rigid piece of plastic that I'm measuring the outside of. That's a pretty easy measurement. Feeling really good about that 58. So maybe the issue that I need to check on is the dimension of the actual hole. So I'm going to go do that. I'm going to go to my other file. I made it 57.7. Well, this is 58 wide. It was fit in a 57.7 hole. Doesn't seem quite right. So I'm going to go back and remeasure. $57.8 maybe. So I have a width for my piece that's wider than the width of the hole. Now I want you to think about this. When you put your connector piece in there, is it snug? Let me ask you, is it snug? When you put your connector piece into the wood, is that a pretty snug fit? I mean, trying to take it out is kind of tough, right? How do they create a snug fit? What are these pieces made of? Not wood. What's this material? There's some type of plastic, right? And plastic bends, right? It bends a little bit. And so when they manufacture things, they take into account tolerances. And sometimes with plastics, because plastics bend, and they know plastics bend, they sometimes make them a little too big or a little too small for whatever their purpose is, right? So even though this may seem like a contradiction of numbers, it is what it is. So we're going to leave those numbers, even though they seem inconsistent, we're going to leave them. We're going to leave them, okay? And that's where we'll stop today.